Hey Defenders, welcome back. In this video, I want to discuss what a honeypot is, and let's go ahead and stand up one of my favorite implementations of a honeypot server. So stay tuned and let's get into it. But first, time for my shameless plug. If you want to learn more about our company, head on over to opensecure.co. If you would like to hire us for a project, select the Hire Us button at the top of this video. To see firsthand the power of open source technology, take advantage of our interactive demo. Select the demo button and start exploring. Now let's get back to the video. So a honeypot server is a server that resides out on a network that is not running any business critical applications or any business critical services or infrastructure services such as DNS or SMTP servers or anything like that. It is simply a server that is stood up and mimics vulnerable services. So maybe an outdated SSH, it's maybe hosting a vulnerable MySQL server, maybe it would be a vulnerable web application. We could mimic a vulnerable RDP service that when attackers were to scan a box, they would see all of these vulnerable services reported. And what this allows us to do is gather a lot of intelligence around, what attacks are currently ongoing out in the wild, right? What maybe there's some new attack vector that we see a lot of malicious actors trying to exploit. We could then take that information and ensure that our internal servers are not vulnerable to this type of exploit, as well as our internet-facing servers, right, such as any jump servers or bashing servers, anything that would be accessible to the outside world. We could also stick a honeypot in a internal network, right, and use that to maybe identify any malicious insiders that are maybe doing something they're not supposed to be. And we could also, the honeypot would also give us a good indication of if any malware has entered the network, or if an actual, if a attacker were to actually breach the network, and hasn't dropped any malware yet, is still doing some reconnaissance, and we see them interacting with our honeypot server, we know that's a good indicator of, hey, someone's on the network and is doing something they are not supposed to. So there's a few different type of deployment strategies you can implement. You could, implement it to where you give it access to the internet. So anyone scanning the internet could potentially run across this honeypot server. And you take that to do your own type of research, or you can stand it up internally and not expose it to the internet, but this way you have the ability to catch any potential malicious insiders, or if malware has actually entered into the network, and hopefully catch this before it's able to do a lot of damage, right? So let's go ahead and jump into that. So there's a awesome GitHub called TPOT, and this is a project that is a all-in-one honeypot. So it takes advantage of Docker to host a lot of open source honeypots, right? So we can mimic a vulnerable Cisco ASA. We can mimic a vulnerable SSH, a vulnerable web application. There's look at all these services here these are all different kind of honeypots that we can stand up to capture malicious insiders and traffic, and is pretty easy to install and get familiar with, and so let's go ahead and jump into that. And all right, so I have an Ubuntu box stood up here. There's a few different installation strategies you can use. They have a pre-built ISO that's provided. So if you're running, VMware or anything like that, vSphere, you can just you can grab the ISO and just load a VM with that ISO. That's an easy way to do it. You could stand up an Ubuntu box and run clone their repo and run the install script, which is what we'll do. You can create your own ISO image. There's a lot of different deployment strategies you can use. A few hardware requirements. They recommend at least 8 gigs of RAM, 128 gig SSD. Of course, you could also just have hard disks as well. A network via DHCP. So you can also set this to just a static IP address when deploying it within your network. You can, if you are standing it up in a network that isn't exposed to the internet, and you're not using DHCP locally within your internal networks, you can set this to a static IP address, no problem. So, when you'll see that later in the demonstration. And then they also recommend, a non-proxy internet connection, because we're going to be going out and grabbing Docker images, and that's all handled on the install script, but you will need access out to the internet. And so we're going to go ahead and install with the post install user. So I've stood up an Ubuntu box here, and now I am ready to install. So I like to go into opt. I probably have to install git. Oh, I am on Ubuntu. So what is it? Apt git install -git. Okay, we already have that, so I'll go ahead and clone the repo. And I'll go ahead and navigate into this directory here. So they have an ISO/installer directory. And then if I list this out, we see our install.sh script. So we'll go ahead and run that. And I'll go ahead and fast forward the install. It is kind of a long install, and also depending on bandwidth capabilities in your network. But I will leave in some important config changes that we can make. So here it's warning us that it is going to change our SSH service. So one of the honeypots that runs within a Docker environment, I believe it's CalRye, is a honeypot that mimics a vulnerable SSH service. So here it's warning us that they are going to run another service on port 22. They'll run this CalRye service, which will be the vulnerable SSH, and that are now the port that we'll use to actually SSH onto the box will change to 64295. So I'll go ahead and confirm that. Now it's asking me to download a version of Honeypot, of TPOT. So I'm going to go ahead and go with the standard. This deploys everything. There's a few other variations we can do depending on the type of network that we're deploying this in. There's an industrial deployment to where it basically stands up different variations of these honeypot services, right? And so maybe we want to mimic some vulnerable like PLCs, right? If I'm in a manufacturing plant, or if I'm in a medical plant, right? Maybe or a network that serves medical devices. Maybe I want to mimic some vulnerable medical devices. And so they have a few pre-configured options that you can select depending on where you're wanting to run, depending on what services you want your overall honeypot server to mimic. We'll just go ahead and go with the standard. I'll go ahead and hit OK. It's asking for a username, and I'll just go ahead and say admin. And it's asking for a password of the web user, and I'll just say, please subscribe. And then I'm asking to repeat that. And so what's kind of going on under the hood is TPOT will actually stand up its own Elastic and Kibana cluster to log that itself, right? So it stands up a Kibana and Elasticsearch cluster to present to us the attacks that are ongoing. But in this little mini series of setting up our honeypot, we're actually going to point it to our own already pre-configured Elasticsearch and Kibana service. So in the event that you stand it up internally within your own network and you already have an Elasticsearch cluster already configured, we can just go ahead and take advantage of what's already there. Of course, if not, you can allow TPOT to stand up its own Elasticsearch and Kibana service, to where you'll then be presented a web UI that we can use to actually view the alerts. So here now it's pulling the different Docker images of the various different Dockerized honeypots that it's running. So we see like Honeytrap, Mailoney, RDPY, and those all correlate to different Dockerized honeypots that we are going to run. It also takes advantage of Suricata to listen and capture packets that are on the interface that's exposed to either the internet or to your internal network. So will also capture Suricata alerts. And if you're unfamiliar with Suricata, it's a network intrusion prevention system, and will give us insight into what network packets are hitting our honeypot server. All right, so now the install is done, and as you can see, the script has called to reboot the box. And so what it'll do after a reboot is a few things will change. We will now log on we will SSH via port 64295. And we could also use our root user or whatever user account you created when you first stood up the Debian box. So we'll now SSH onto port 64295. Right, and we can see that the server actually is listening for SSH connections on this port. I'll go ahead and say root, and please subscribe. And now you can see we've logged onto the box. And you'll notice a few things. So if we run a netstat to look for ports that are listening for connections, we see all of our honeypots, right? So normally we would only have like SSH or a few others. We can actually see our SSH, our non-vulnerable version of SSH, right, running on 64295, where our vulnerable version of SSH is running on port 22, that you see here. And so what the TPOT is doing is mimicking a vulnerable SSH service on port 22, which of course is the standard port for SSH connections. And so we can also, since we actually installed the Elastic and Kibana part of it, we should be able to log into this guy via a web browser. So go ahead and navigate to our web browser. So 192.168.49.93 and 64297. You can see we're getting a prompt back to log in, and it's using Nginx to ask for identification. So go admin and please subscribe. And we're now interacting with the web UI. And as you can see, we get a link to Kibana and a few of the other tools that we can use. So if we select Kibana, we'll then see the pre-built, and there's a lot of pre-built dashboards that we can click on and navigate throughout, which we'll get into here in a little bit. And so you can see they have some guides on where to place the system. They have some update scripts you can run to if you want to upgrade to a later version of TPOT in the future. There's also a script, I believe it's dps.sh we can run. Yeah, and so we can also run this bash script, which will give us the status of all of our honeypots and also some of our services such as like Elasticsearch, right, that I'm using, and Kibana and Logstash. So these are infrastructure that's kind of put in place to capture our logs. Of course, if you already have your own Elasticsearch cluster already stood up locally in your environment, then you don't need to run this service. And so if we navigate into the TPOT directory here, and if we go into the etc directory, you notice there's a tpot.yaml. And this is a config file that we can turn off various honeypots if we want to, right? So say, for example, I don't want to load this Cisco ASA service. So I don't want the TPOT to mimic a Cisco ASA. Maybe I don't have any of those in my network and it just doesn't serve as a purpose for me. I can just comment out these lines, or I could in that way comment all the way out, all the way down, right? Or maybe I want to change the port that it's listening on in the protocol. So instead of port 5000, maybe my Cisco ASAs, I know if I do have some within my environment, they're listening on a different port or port and protocol. I could change that here if I wanted to. And you'll notice that all services are listed here in their ports. So like, for example, if we go to our Calri one, which mimics a vulnerable SSH server, we see that it's listening, our service, sorry, we see that it's listening on port 22 and also on 23. And we can also see where it's outputting its logs to. And if we want to forward the logs to Elasticsearch, we would, stand up our Wazoo agent on here per se. We're going to do that in a near video in the future here. But this service also runs as TPOT. So if I do a systemctl status TPOT, so say I make a change to the tpot.yaml, I would just go ahead and restart the TPOT service. So if I do a restart, so it'll restart, and if we run our script again, we can see that now the services are coming back up, right? And again, as I mentioned before, this is relying on Docker to run. So Docker's spinning up all these containers that are running these various vulnerable services, right? And so also what we can do is let's see if we have some stuff coming in. So there's some pre-built dashboards already done. Let's look at our vulnerable SSH service. If we select this Calri dashboard here, oh, well, of course I've just restarted, so Elasticsearch will probably take a sec to come up. Okay, it looks like it's starting to come up now, so we should be able to refresh here, and we should be able to see what's going on. And here we can actually start to see some attacks coming in already. Right? We see our various honeypots. So let's look at who's attacked our Cisco ASA. And granted, this is opened out to the internet, so this guy is just going to get spammed. And let's actually see if we can create our own. So, if I'm a malicious actor out on and scanning for, what's something exposed to the internet that I could possibly take advantage of, right? So if I run nmap and let's see what if we were to run a scan against our honeypot, what would the attacker see? And so we'll go ahead and put our target in, 244.49.93. Yeah, we'll leave it at an intent scan. We'll go ahead and scan. And we'll see what nmap reports as, what services are open and listening. Maybe if it's able to enumerate any versions. All right, and we can see nmap is starting to detect all of the ports that are open. Right. I mentioned as well that it mimics a vulnerable web app. So if we go, usually web applications, HTTP would be on port 80. So let's see. So here we have our vulnerable web app that the TPOT has spun up. And I'm sure we're probably, if we were to hit this with like GurBuster or a tool that implements web attacks, we would also capture those as well, because to an outside user, this looks like just some welcome site. Granted, this isn't sophisticated, and we can create our own HTML page if we would like to maybe present a more legitimate application, right? Because one thing to take in mind with a honeypot is you also don't want to make it too sweet, right? You don't want to make it too obvious that this is probably a honeypot and then shy an attacker away from actually trying to get a stronghold of this, right? So if we go back to like our nmap scan, for example, we see all these ports open. I would hope no one in a legitimate network, serving a legitimate network or server, would have this much open on it. But I mean, it does happen, but so if you were to host this, just internet facing to capture all attacks that are spawning from the internet, it's probably fine to leave all this open. But if I'm serving this on my internal network, right, and I don't want to make it too obvious, then that's where taking out some of these services that are running within the tpot.yaml file is a good idea. Right, so then that way you're not exposing all of these random ports, right? And so we also have something listed on 443. So let's look at what that web app is. So here we're just presenting a login page, a very basic login page. And what's also cool is, if we were to maybe try to attack this, so if I did like an admin and then like a very basic SQL injection of like 1 = 1 or something and tried to log on, we're now capturing the values that an attacker would be actually trying. So if we go back to our Kibana page, we can see a lot of attacks starting to come in. So if we look at Tanner, which is the service that runs our web app, we'll probably see, so we can see the IP address that is attacking the Tanner, which is our web app. So that's just the service that it's called. If we come back up to here and select the Tanner, it's a web application honeypot sensor, right? So it's a combination of Tanner and Snare. So those two work together to service these. But so we get that starting to come in. If we select the Cowrie, this is our vulnerable SSH port. So what's also cool is we're capturing usernames that people are using, right? The usernames, and we also get the password, which is cool. So, what I could do is say I have this hosted on the out on the internet. I could then correlate this to say, hey, have any of these usernames? Granted, some of these aren't even usernames, but have any of these usernames logged onto any of my internal machines, right? And we capture the passwords, which is nice as well. And we're also starting to collect Suricata alerts, right? So as I mentioned earlier, Suricata is sitting on our network interface and is capturing packets and looking at attacks. So like if we look at some of these, we can see it's trying, we're getting traffic that's trying to exploit a known CVE. All right, let's see if we can go to the actual Suricata dashboard. Here we go. And these are all pre-built dashboards, which is nice. So I didn't create any of these. This comes bundled with TPOT, and we can also see geolocation. So we can see who's all trying to take advantage and attack this Honeypot server, right? And we get HTTP methods used, so we can see that someone's trying to pass some commands in via HTTP traffic, right? We can see a chmod. They're trying to do some directory traversal. We get Suricata alerts, the rule descriptions. We can see who all is triggering these. So we also see some IPv6 sources coming in, and we really get a wealth of information. Oh, and we're also categorizing out a mass scanner. So I wonder. So we can see like Netherlands, someone from the Netherlands and the Republic of Lithuania are using known scan engines to and I imagine they're just mass scanning the internet and trying to hit anything that they can reach. If we go back to our Nmap scan, we still see there's a few minutes left remaining, but we get a wealth of information. And we could also go like to our just overview and go to our Discover tab here and also load all of the raw alerts, right? So if I expand this guy, so this is actually my Nmap scanner, right? Triggering some alerts, and it looks like, yeah, sending some HTTP requests to my Honeypot server. So we see a lot of my traffic coming through here, so that's good. So our Nmap scan is being picked up. We see, okay, so here we see a Suricata alert for a potential CVE exploitation. And we can see the payload that they're passing in, right? And this is coming over HTTP, I believe. So we have it decrypted, and we're able to actually see the payload come through, which is really cool to have. You can see that when TPOT installs, it generates a random host name that it assigns to it. What I also like to do though is change if you go into Etsy into host name here, you can see that relates that. What I like to do is change it to an actual naming convention that especially if this is on an internal network, that matches, so say for example I have a naming convention of like prod 5625 or 5625, right? I could change it here, so then if someone, and then reboot the server, so if someone were to scan it, the host name wouldn't come back as something that may indicate that, hey, this is a honeypot server or something that isn't legitimate. So any kind of tricks I can take, to trick an attacker is definitely something that I want to implement. Again, we don't want to make it too obvious as to that this is a honeypot server, right? We want this to look as legit as possible, so people interacting with it aren't made aware of its actual purpose. And all right, so it looks like our Nmap scan has finished. So we can see what all it has fingerprinted for us. We can see, an open FTP, open SSH. We also get the versions, right? Possibly Telnet, which is actually correct. Telnet is listening on port 23. We can see Nmap was trying some passwords to use to log in. A HTTP service, right, which is right. We looked at that web app earlier. Same for HTTPS on port 43. We can see all of these scans so this is, what would be reported back to an attacker. So an attacker would, see some of this output. This is a server that looks pretty vulnerable, right? And there's a good chance of me successfully being able to break into this. And, what this could do is, like we've talked about, identify malicious insiders or maybe malware that's made its way onto the network. Or, if you stick this up, like maybe in your DMZ and something that's internet facing, you can have attackers waste their time just on this Honeypot server thinking that it's something legitimate within, your company's network. And, you can see what IP addresses they're coming from, and possibly get those blacklisted before they even try to break into any of your actual legitimate web app servers that you're hosting, or any jump servers, anything like that. So time is always money, right? Especially in our world. So anything that we can do to slow these guys down and identify these guys before they start to interact with legitimate services and servers is always a plus in our book. So I appreciate your guys' time. We'll dive a little more into this here in the next few videos. We will get a Wazoo agent installed on this guy. We'll get the logs forwarded over to a already pre-configured Elasticsearch cluster and set up some alerting on this. So we'll be made aware in real time of when someone is interacting with our Honeypot server. So I appreciate you guys' time, and I will see you in the next video. And as always, let me know down below what you liked or disliked about this video, any errors I may have made, as well as recommendations for other open source tools you think I should explore.